Hello students, how are you all? I hope that you all are good. And as we know, the series of units and measurements is going on, and we have successfully finished the 6 lectures. In a previous lecture, that we are discussed about errors. Okay, so what is the meaning of error? What are the types of error? Okay, the formulas of true value or mean value, absolute error, mean absolute error, relative error, percentage error, and all these things with examples that we are discussed in a previous session. Okay, so the series is going on. This is the seventh lecture of units and measurements, and today we are going to discuss about a combination of errors with examples. So what are the combination of errors in case of addition, subtraction, multiplication, division? So the combination of error whenever the quantity having power, and all these things that we are going to discuss in this session. So, my name is Rakesh Kanganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the session? Okay, very good. So, what is the session going on? Units and measurements. And this is a class number 6. Sorry, 7. 6 already we are finished. Right? Okay. What is the topic? Combination of errors. Combination of errors. Okay, right. So the first one, let us say combination of errors in case of addition. Addition. Okay, if the physical quantity Z is a combination of physical quantities X and Y, and they are related as Z is equals to X plus Y, and they are related as Z is equals to X plus Y. Okay, so this is equation number 1. If delta X comma delta Y and delta Z are the absolute errors in X comma Y and Z. Okay, right. Therefore we can write above equation as Z plus or minus delta Z, which is equals to X plus Y plus or minus delta X plus or minus delta Y. So this is called a combination of errors in case of addition. Are you getting? So I'm just to take a physical quantity Z, which is related to the two physical quantities X and Y as a Z is equals to X plus Y. Okay, I'm taking a delta X, delta Y, and the delta Z are the absolute errors in X comma Y comma Z. So now we can write the equation. So combination of errors in case of addition as Z plus or minus Z plus or minus Z is equals to X plus Y plus or minus delta X plus or minus delta Y. So this is called a combination of error in case of addition. Okay, so the maximum possible error in Z, the maximum possible error in Z is equals to delta X plus delta Y. What is the maximum possible error in Z? Delta X plus delta Y. Just note down. Okay, and percentage error in Z. Percentage error in Z is equals to delta X plus delta Y divided by X plus Y into 100. So this is what percentage error in Z. Are you getting? Okay. So right, have a look. In case of second one, in case of subtraction, combination of errors in case of subtraction. Same relation I'm taking. So Z is a physical quantity which is related to the two physical quantities x and y as x minus y. Okay, let us say this is equation number 1, whatever it is. If again delta x comma delta y and delta z are the absolute errors in x comma y and z, therefore we can write, so z plus or minus delta z is equals to x minus y plus or minus delta x plus or minus delta y. So this is what combination of error in case of subtraction. Are you getting? Okay, so note maximum possible error, maximum possible error in z is equals to, have a look. So here what is the maximum possible error in z is delta x plus delta y. I'm talking about a maximum. What is the meaning of maximum? Here we are having plus or minus, plus or minus. For example, delta x is equals to 2 plus or minus delta y is equals to 3. What is the maximum value? It leads to 2 plus 3, 2 minus 3. Okay, 2 plus 3 is equals to 5, 2 minus 3 is equals to how much? Minus 1. Are you getting? We are talking about maximum value. So in these two, what is the maximum value? Delta x plus delta y. If you made an addition, then you will get what? Maximum value. Here also we are talking about what? Maximum value. So how we will get the maximum value? Delta x again plus delta y. So this is the maximum possible error in case of subtraction. So in case of addition and subtraction, maximum possible error is same. Are you getting? Right. Next, percentage error in z. Percentage error in z. So which is equals to delta x plus delta y divided by x minus y into 100. So here change comes. Here x plus y is there. Here x minus y is there. Okay. So this is what? Percentage error in z. Are you getting? Okay. Pause the video and write the notes. 3, 2, 1, go. Alright. Let us see the third one. The combination of error in case of multiplication. Okay. Now at this time, the physical quantity z is related with x and y as z is equals to xy. Z is equals to what? X into y. So simply I am applying a log on either side. So log z is equals to, we can write what? Log of xy. Log of x into y. So log z is what? Log z only, which is equals to log x into y. Log of a into b. So log of a into b can be written as log a plus log b. Log a plus log b. Already we are discussed in a basic mathematics used in physics concepts. Okay. So log a b is equals to log a plus log b. So I'm just differentiating either side. Differentiate on either side. So what is the differentiation of log z? Already we are discussed. The differentiation of log z is how much? 1 by z. Differentiation of log z is what? 1 by z dz, which is equals to differentiation of log x 1 by x dx plus differentiation of log y 1 by y dy. Are you getting? D means what? Difference. I'm just replace this d with delta. So replacing d with delta. So therefore we got delta z by z is equals to delta x by x plus delta y by y. So this is called a maximum relative error in z. This is called what? Maximum relative error in z in case of multiplication. Okay. Z is related with x and y is what? X into y. What we did? Just we are applied log on either side. So log z is equals to log ab. Log a plus log b. So we just differentiate on either side. What is the differentiation of log z? 1 by z dz. Sorry, what is the differentiation of log x? 1 by x dx plus 1 by y dy. Just I am replaced d with delta. Delta means difference, d means differentiation. Okay, so now this d becomes delta z by z is equals to delta x by x plus delta y by y, and this relation is called what? Maximum relative error in z. Are you getting? Okay, let us see the fourth one. Okay, okay, so the fourth one is what? Division. In case of division, same. Okay, so the z is related with x and y as z is equals to x by y. Then what we have to do? Right, so apply log on either side. Apply log on either side. So log z is equals to log of x by y. Log of x by y. Then log z is equals to log a by b. Log a by b, we can write log a minus log b. Log a minus log b. So again, differentiate on either side. Differentiate on either side. So differentiation of log z is how much? 1 by z dz, which is equals to differentiation of log x, 1 by x dx, minus differentiation of log y, 1 by y dy. What we have to do? Replace d with delta. So therefore delta z by z is equals to delta x by x minus delta y by y. So this is in case of what? Division. Okay, combination of error in case of division. Next, what we have to write? Maximum relative error. Maximum relative error in z. So what we are finding? Maximum relative error. So maximum relative error when we get? When we get the maximum relative error? When we are adding the two quantities. So maximum relative error is given by delta z by z is equals to delta x by x again plus delta y by y. In case of division also, this is what? Maximum relative error. Are you getting? Okay, very good. Right, next. Fifth one, combination of error when physical quantity has different powers. Has different powers. Okay, so have a look. Now at this time, z is related with x as z is equals to k into x to the power of n. Z is equals to k into x to the power of n, where k is constant. Where k is what? Constant. So what we have to do? We have to apply log on either side. So log z is equals to log of k into x to the power of n. Log of k into x to the power of n. So log z is log z, which is equals to log k into x to the power of n. Log a into b. We can write log a plus log x to the power of n. Are you getting? Are you able to see the board? Okay, right. So log z is equals to log k plus, see, log x to the power of n is there. Now this log x to the power of n becomes n into log x. Whatever the power term is there, that comes to in front of log. Okay, so differentiate on both sides or either side. Differentiate on both sides. If we differentiate, it becomes what? 1 by z dz is equals to differentiation of log k. Differentiation of log into constant becomes 0 plus n into log x, 1 by x dx. What we have to do? We have to replace d with delta. D with delta. So delta z by z is equals to n into delta x by x. So this is what? Maximum relative error in z. Maximum relative error in z in case of what? whenever the quantity has power n, x, n, whatever it is. Okay, are you getting? Just put the power in front of x and write delta x by x. That's it. Is it clear? So pause the video and write the notes. Let's we solve some example problems, then you will get a clear idea about this concept. Is it clear? Right. So 3, 2, 1, go. Right. So let us see an example. So the example is like this. If z is equals to capital A power P, B power Q divided by C power R. Z is equals to A power P, B power Q divided by C power R. Find the relative error in Z. Find the relative error in Z. So just now we seen that. So what is that? Z is equals to k into x to the power of n is there. So what is the relative error in Z we got? So delta Z by Z is equals to answer. What we got? Just the n comes to in front of x and delta x by x. So this is the relative error we got whenever the physical quantity leads to power n. So do the same thing here. Don't apply log. Okay now. So don't differentiate on either side. Nothing is there. Just follow this concept. Okay. Z is equals to k into x to the power of n, where k is constant. So when we are writing the relative error in z, so don't take a k. That's it. Just put the power, whatever the quantity having the power, just put in front of it and just write delta x by x, or delta a by a, or delta b by b, or delta c by c. Then you will get the answer. So don't do anything applying the log. So doing that, doing that, no, don't worry. Okay, you will get the answer. Solution. So he asking relative error in z. Therefore, what we have to do? Just delta z by z is equals to, what is the power of a? Power of a is what? P. Just put p here into delta a by a. Have a look. N into delta x by x plus, what is the next quantity? B. What is the power of B? Q into delta B by B. That's it. That's it. Plus, what is the power of C? We have R. Just to put R here into delta C by C. So this is your answer. So although if you take log on either side and if you do the differentiate and all these things, you will get the same answer. Okay. So this is what maximum relative error in Z. Are you getting? Just to place the power in front of A and just write delta A by A. Just to place the Q in front of B, write delta B by B. Just to place R in front of delta C by C. Are you getting? Easy one. Any doubts? Right. Let us solve this example. So if example is like this, t is equals to 2 pi into under root of L by G. Find out relative error in Z. Find relative error in Z. Pause the video and try the solution. 3, 2, 1. Have a look. Just square on either side. Square on, so not Z, in T. Sorry, very sorry. Square on either side. Okay, square on either side. So T square is equals to 4 pi square into L by G. What we have to find? Relative error in T. How we have to write? Just see here, T power 2 is there. Just write 2. Then what we have to write? Delta Z by Z. Here, delta T by T, which is equals to 4 pi square. It is constant. Constant we don't take. We don't take constant. So here L is there. L power how much? 1. So that means it becomes delta L by L. 1 into delta L by L is nothing but delta L by L. Plus, what is the denominator? We have G. Just to write delta G by G. So this is what relative error in T, or delta T by T is equals to, if you send 2 to that side, it becomes delta L by L plus delta G by G. Are you getting? I hope that you got the idea how to write the relative error in any physical quantity. Is it clear? Pause the video and write the solution. 3, 2, 1, go. Okay, right. So let us see some examples based on this concept. Okay, right. So these are the some examples on combination of errors. So have a look the solution of these examples. So what is the first one? They are given L1 is equals to 11.5 plus or minus 0.1 centimeters, and the second one L2 is equals to, they are given how much? 7.8 plus or minus 0.1 centimeters. Okay, so what we have to find? We have to find the difference between L1 and L2. So here 11.5 shows L1 and 0.1 shows delta L1. So what is delta L1? Absolute error in L. So here 7.8 shows L2, and again 0.1 shows what? Delta L2. What is delta L1, delta L2? Absolute errors in L1 and L2. So in a second concept, combination of errors in case of subtraction, we solve like this: z is equals to x minus y. Okay, so delta z, delta x, comma delta y are the absolute errors in x, y, z. Right, what we did? So z plus or minus delta z is equals to x minus y plus or minus delta x plus or minus delta y. So this is what combination of errors in case of subtraction, right? So if we want to find the maximum possible error, what we did? We take a maximum possible error as delta x plus delta y, delta x plus delta y. So then we get the answer. So we get the answer for this if we did like this. Is it clear? Just at the place of x, we have what? L1. At the place of y, we have L2. At the place of delta x, we have delta L1, and y we have delta L2. Therefore, the difference between L1 and L2 is given by, which is equals to L1 minus L2 plus or minus delta L1 plus delta L2. Same thing I am written. So why here I am taken plus? We have to get a maximum possible error. So that's why here I am taken delta L1 plus delta L2. Is it clear? Just substitute the values, then you will get the answer. So what is L1? L1 is what? 11.5 minus what is L2? 7.8 plus or minus what is delta L1? 0.1 plus what is delta L2? 0.1. Okay, so 11.5 minus 7.8, 7.8, 11.5 minus 7.8, so 15, 8, 9, 10, 7, so 10, 10 minus 7, 3.7. So 3.7 plus or minus 0.2 centimeters. So check the answer. Answer is there in a given options. Have a look. 3.7 plus 0.1. This is not an answer. 0.7. This is not an answer. So option C is the correct option. Are you getting? 3.7 plus or minus 0.2. Okay, right. So let us see the second one. So what they are given? R is equals to V by I. Ohm's law given. Okay. So the value of voltage is equals to how much? 100 plus or minus 0. Plus or minus 5 volts, and current I is equals to 10 plus or minus 0.2 amperes they are given. Okay, so V given, I given. So we have to find what? Percentage error in R. Percentage error in R we have to find. So percentage error in R. So how we find? Already we know that. So what is that? So in case of division, we seen that if any relation is like this, if z is equals to x by y, then we got the relative error formula. So what is the relative error formula there? We get delta z by z is equals to maximum. Okay, so delta x by x plus delta y by y. So we got this maximum relative error in case of division. So we got this formula. Okay, so here at the place of z we have r, At the place of x we have v, at the place of y we have I. So simply we can write, so delta r by r, which is equals to delta v by v plus delta I by I. Delta I by I. What they are asking? They are asking percentage error. Just multiply this with 100, you will get percentage error. Already in errors concept also we are discussed percentage error, absolute error, mean absolute error by mean value into 100, mean absolute error by mean value into 100. Already we are discussed. Same thing here I am doing. So delta v by v into 100 plus delta I by I into 100. Just substitute the values, we get the answer. Okay, so what are the values of v and I? Have a look. This equals to delta v, so this is v and this is what? Delta v. So delta v by v into 100 plus delta I. What is delta I? 0.2 divided by I. What is the value of I? 10 into 100. Are you getting? Okay, so 10 1 0 cut, 100 100 cut, so 5 plus 0.2 into 10 we got. See, 10 ones are 10 tens are 100, so 100 100 cut. So 5 plus 0.2 into 10 we get 2. 5 plus 2 7 percentage. Answer is there? Yes, option B is correct. Are you getting? Any doubts? Just I am write the relative error. So they are asking what? Percentage error into 100. That's it. So absolute error by mean value into 100 gives what? Percentage error. Any difficulty is there? Easy problems, right? Okay. Pause the video. Write the problems and the solutions. 3, 2, 1, go. Right. So let us see the third problem. What is the third problem they are given? They are given density is equals to m by pi r square L given. What they are asking? Percentage error in D is equals to how much? Already they are given percentage error in m comma r comma L. So what are those? 2 percentage, 1.5 percentage and 0.8 percentage they are given. So what they are asking? They are asking find the percentage error in D. Pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. I am going to solve. Solution. What we have to find? Percentage error in D. So how to find the percentage error? In a last concept I told you that. What I told you that if z is equals to something into x to the power of n, then how can we write the relative error? So just delta z by z, just remove constant, put the n in front of x, just write delta x by x. So this is what? Maximum relative error in z or relative error in z. So if you want to find percentage, just put into 100 into 100. So what we have here? D is equals to m by pi r square L. So delta d by d is equals to m is there, delta m by m plus pi, it is a constant, no relative error. So r square is there, r power how much? 2 is there. So 2 into delta r by r plus L is there, delta L by L. That's it. Any problem? Easy? Okay, easy one. Percentage error we have to find. To find the percentage error, just we have to multiply delta d by d into 100 is equals to delta m by m into 100 plus 2 into delta r by r into 100 plus delta L by L into 100. So this 2 is what? Power of r. Are you getting? So which is equals to delta m by m into 100. Already they are given percentage error in m. How much? 2 percentage. So 2 plus 2 into percentage error in r. They are given how much? 1.5 plus percentage error in L 0.8. So 2 plus 1.5 2s are 3, 0.8. 2 plus 3, 5. 5 plus 0.8, 5.8. So this is what? The percentage error in density. Are you getting? Right, very good. Pause the video and write the notes. Any difficulty is there? Okay, right. So this is the end of the today's session. I hope that you are understand this concept combination of errors, how to write the combination of errors for addition, subtraction, multiplication, division, and the physical quantity leads to power n, and what is delta L, what is L in a given values, how to find the relative errors, and all these things. Okay, so we will meet on our next lecture. Until then, stay tuned. This is Rakesh Kaniganti signing off. Jai Hind.